Okay, we're going to continue a discussion of writing the basic program that sums up a series of numbers. We have already written the program that sums up numbers that look like this. We take 1/2 plus 1/4 plus 1/8 plus 1/16 and so on. And doing the in the basic program, we found that that sums to 1. Okay, here's what the program looked like here. Here's a listing of the program right here. So my suggestion is that if you don't have that up in your basic programming window, that you pause the video right now and write down these statements so you have the starting point of what we're doing. Okay, there's just 7 lines of code. Shouldn't take you long to write it out. Okay, the first line 10 inputs the value x, and x is going to be this number right here. Okay, that's the first line of code. The second line of code inputs the number of terms that we take in the sum. So, for example, this right here shows 4 terms in the sum. The sum continues. After 1/16th, we get 1/32 and 1/64 and so on. If the So we begin by using a for loop. We begin by setting the initial value of our sum variable equal to 0. And let me write that right here as being sum equal to 0.0. Okay, there. So let me do a list again. Okay, so I forgot to put 30. 30 sum equals 0.0. There, list. Oh, just putting in 0 there. Either it's doing what it's supposed to be doing, or I'm doing something wrong. I don't see what I'm doing wrong, so it must be doing what it's supposed to be doing. Okay, then we do 40 for I equal 1 to n. So we're going to go through all n terms here. So we're going to say we're going to sum up n terms, and this is how we do it, setting sum equal to 0 for I equals 1 to n. Then we do sum equal to sum plus 1 over x to the I. So this will be 1/2 when I is equal to 1. It'll be 1/4 when I is equal to 2, and so on. So we execute this for loop, and it sums up all n terms, the first n terms of the sum, and then we print out the value. So, and let me run that code for you again here. I'll put run and input the value of x. We'll say 2. Okay, number of terms in the sum, let's say 5. And it comes out to 0.96875, close to 1. As I say, good enough for government work. Okay, now, so that's summing up the first 5 terms of this sum, not quite equal to 1. How do we know that this sum sums to 1? I mentioned that in mathematics we have a result that shows us that. And suppose I want to set x equal to 3. If I set x equal to 3, I'm summing up this sum, 1/3 plus 1/9 plus 1/27th. So it's 1/3, then 1 over 3 squared, 1 over 3 cubed, 1 over 3 to the 4th, and so on. So I'm summing this up. So here's one way that we can evaluate it to see how many terms, see what the value of the sum is supposed to be, to see if the computer program is executing properly. So in order to do that, what I want to do is I want to say, okay, let's set this sum right here. Let's say this equals sum, okay? And I know that sum is equal to 1/3 plus, and then I have 1/9. Let me write this in red now. 1/9 plus 1/27 plus 1 over 81 plus dot, dot, dot. So it's 1/3 plus all of these terms right here. And that's equal to sum. Now this term, what I'm going to do is I'm going to factor that one third out. So I can write this as 1/3 plus, and now I'm going to write this as 1/3, factoring out the 1/3, times, if I factor out a 1/3 from 1/9, I get, say, edit, undo. If I factor out a 1/3 from 1/9, I get 1/3. If I factor out a 1/3 from 1/27, I get 1/9. If I factor out a 1/3 from 1/81, I get 1/27 plus dot, dot, dot. Okay, I'm just factoring out a 1/3 to there to get this. And this is still equal to sum. But notice this thing right in here is exactly the original sum that we started with. Okay, this was this thing up here. This is what we started with. So this itself must sum the sum. So what I get then is that 1/3 plus 1/3 times sum equals sum. Okay, I'll subtract 1/3 from sum from both sides of the equation, and I get that 1/3 equals sum minus 1/3 sum. So I subtract 1/3 sum from both sides of the equation. So I have this expression right in here, this one right in here. Now let me rewrite this up here, okay, because I run out of space down there. I'll write it in green, okay. Now sum minus 1/3 sum is 2/3 sum. So I have 1/3 left side of the equation equals what's on the right, sum minus 1/3 sum is 2/3 sum. Okay, now I multiply both sides by 3/2. 3/2 times 1/3 equals 3/2 times 2/3 sum. Okay, 3/2 cancels with 2/3 here, and I get 3/2 times 1/3. 3/2 times 1/3 is 1/2. So here's what I get. I get 1/2 equal to sum. So my result is that this thing right here, this sum right here, should be 1/2. So I've now proven using some algebra that that sum is 1/2. Now let's go back to this and let's try running the program. Run, value of x is 3. Number of terms in the sum is equal, let's pick 100. Value of the sum is 1/2. So the program executes and gives us the answer which the algebraic analysis gives us. So we can be pretty confident that the program is executing properly. So until next time.